Hello everyone, welcome back to another video on the Education Always channel. Today we will be looking at isotopes. In this video we will cover isotopes, relative atomic mass and calculating relative atomic mass. Atoms of the same element must have the same number of protons, but they can have a different number of neutrons. Atoms of the same element with different numbers of neutrons are called isotopes. Isotopes of an element have the same atomic number but different mass numbers. The three types of hydrogen. All hydrogen atoms contain one proton and one electron, but they can contain different numbers of neutrons. Hydrogen 1 is the most abundant, which means the most common, isotope of hydrogen. As you can see on the screen, hydrogen 1 has one proton and one electron, so 0 neutrons. Hydrogen 2 has one proton, one electron and one neutron. An isotope is named after the element and the mass number of its atoms. For example, carbon-12 is an isotope of carbon with a mass number of 12. All three isotopes of hydrogen have identical chemical properties. This is because the number of electrons determines chemical properties, and all three isotopes have one electron in their atoms. Now, relative atomic mass. The relative atomic mass of an element is a weighted average of the masses of the atoms of the isotopes. It takes account of the abundance of each of the isotopes of the element. Relative atomic masses can be found in the periodic table. They have the symbol AR. It is important not to confuse mass numbers and relative atomic masses. Mass numbers are always whole numbers. This is because protons and neutrons can't be split into parts. Relative atomic masses are often rounded to the nearest whole number, but are actually not whole numbers. For example, the relative atomic mass of chlorine is 35.5, rather than a whole number. This is because chlorine contains two different types of isotopes, chlorine-35 and chlorine-37. The carbon-12 atom is the standard atom against which the masses of other atoms are compared. The relative atomic mass of an element is the average mass of its atoms compared to 1/12 the mass of a carbon-12 atom. The relative atomic mass AR of an element is calculated from the mass numbers of its isotopes, the abundance of these isotopes. Chlorine naturally exists as two isotopes, chlorine-35 and chlorine-37. The abundance of chlorine-35 is 75% and the abundance of chlorine-37 is 25%. In other words, in every 100 chlorine atoms, 75 atoms will have a mass number of 35 and 25 atoms have a mass number of 37. To calculate the relative atomic mass of chlorine, you do the total mass of atoms over the total number of atoms. So 75 times 35 and 25 times 37 over 75 and 25. This gives you 3,550 over 100, which rounded to one decimal place is 35.5. Notice that the answer is closer to 35 than it is to 37. This is because the chlorine-35 isotope is much more abundant than the chlorine-37 isotope. And that's it everyone, thanks so much for watching. Please don't forget to like and subscribe for more. Any questions, pop them down in the comments. Thank you, bye.